In this video, we are going to solve example on probability distribution function. So consider random variable whose PDF is given as small fx of x equal to e raised to minus x u of x, and we are supposed to find out first CDF and then the probabilities of this random variable for different conditions. So let us start with the first solution. We need to find out CDF. To find out CDF, we know that relationship between PDF and CDF. So CDF is denoted by capital Fx of x equal to, it is integration from minus infinity to x fx of x dx. So CDF is integration of PDF. So substitute the value in this equation. So minus infinity to x, fx is e raised to minus x u of x dx. So if we simplify it further, so we know that u of x is equal to 1 and 0, 1 for x greater than or equal to 0 and 0 for x less than 0. So let us put this value in the above equation. We get, now here the limits of integrations are going to change from 0 to x. Lower limit is minus infinity, but u of x starts at 0. It doesn't have any value below 0, or its amplitude is 0, so the entire integration will become 0. So our integration limits are going, the lower limit is going to change to 0 and upper limit is x, and here the upper limit of unit step signal is infinity, but we do not know the value of x, whether it is greater than infinity or less than infinity. So upper value will be x, e raised to minus x u of x will be 1 dx. So if we take its integration, we get e raised to minus x upon minus 1 with the limits 0 to x. Simplify it further. So upper limit is x, so e raised to minus x minus e raised to 0 divided by minus 1. So here e raised to 0 is 1, so e raised to minus x minus 1, and if we multiply it by minus sign, so it becomes minus and this becomes plus. So we get the answer of CDF as 1 minus e raised to minus x. So we have obtained the solution for CDF from the given PDF. Now let us go for the second part. So second part is to find out probability of x, which is random variable, less than 1. Second part is probability of capital X less than 1. Now see, in this particular example, we have CDF as well as PDF equation available with us. So now here, to solve this example, we can make use of properties of either CDF or PDF. You are going to get the same answer. So here we'll see both the properties. So to find out P of x less than 1, we have the definition of CDF. So it states that fx of x is equal to probability of random variable x less than or equal to small x. So using this formula, we can find out the probability of random variable less than or equal to 1. So see, probability of x less than equal to 1 will be equal to fx of 1, and we have the equation of fx. Substitute value of x as 1 in this equation, so it is 1 minus e raised to minus 1. So p of x less than 1 is equal to, if we find out the value, its value is 0.6321. This is the value of probability for random variable for less than 1. Now next is the third part, probability of random variable between 1 to 2. Okay, before that, see this second example we have solved it using the CDF part. Now let us see it in the third part how we can make use of CDF as well as PDF equations. So in the third part, we need to find out probability between 1 to 2. So here we have two options. Either we can go with CDF or we can go with PDF also. So let us see the equations for both, and either of equation we can use and find out the answer. So if we go with CDF, we have probability of x1 to x2 is equal to CDF of x2 minus CDF of x1. Similarly, if we go with PDF, so for PDF, we can make use of the equation. So probability of x1 to x2 can be obtained using integration from x1 to x2 fx of x dx. So we can use any one formula out of these two, it will result into the same answer. So in the previous part we have used the formula for CDF. Now here let us make use of the PDF formula. So you can try it for CDF also, you will get the same answer. So for PDF, here we need to find out the value of random variable x between 1 and 2. So let us integrate it from 1 to 2, and fx of x dx is given as e raised to minus x u of x. dx. So if we integrate it, unit step signal in this range has value 1. So simply the integration will be e raised to minus x upon minus 1 with the limits 1 to 2. So we get the answer as e raised to minus 2 minus e raised to minus 1 upon minus 1. And if we simplify it further, we get the answer as 0.2325. This is the required answer for the third part. Now the fourth part. So for fourth part, we need to find out probability for x greater than 2. So here we can make use of both the formulas. So let us see the formula for PDF. So for probability of x greater than small x, we can find out it as integration from x to infinity fx of x dx. Similarly, if you want to find out the probability of x greater than 2 using CDF function, we can use it as, so probability of x greater than 2 will be equal to 1 minus probability of x less than or equal to 2, which is equal to 1 minus CDF of x of 2. So using CDF also we can find out the answer for this fourth part, and using PDF also we can find out the answer. So we can use any one. So let us go with PDF. So integration from, it is probability of x greater than 2. So integration from 2 to infinity fx of x So fx is e raised to minus x u of x dx. So substitute these values in this equation. Integration 2 to infinity, u of x is 1 for this interval dx. So e raised to minus x upon minus 1 with the limits 2 to infinity. So upper limit is infinity, so e raised to minus infinity minus e raised to minus 2 divided by minus 1. So we know that e raised to minus infinity is 0. So 0 minus e raised to minus 2 upon minus 1. So 0 can be neglected, so minus minus becomes plus. Our answer is simply e raised to minus 2. So it is probability of x greater than 2. So if we find out the value of e raised to minus 2, 0.1353. So this is the answer for fourth part. So just to summarize again, here PDF was given. From PDF we have obtained CDF. So CDF is nothing but integration of PDF, and then we have with us CDF as well as PDF, and the rest three parts can be obtained either by using the properties of PDF or CDF.